Next. We have to discuss the relevance of positive and negative direction cosines. So, what we have seen. So please note here that direction cosines can be positive also, can be negative also. And the concept of the direction cosines, the very first time you learned in the vector analysis, in the form of the vector, not in the lines. But vector has a support, so we can call that we can associate direction cosines with the line as well. Now, direction cosine of a line, when I say AB, actually, when I say line AB or line BA, one and the same thing. But when I say vector AB, vector BA, that is different. So to only show that difference, direction cosines are positive and negative. Right? What I mean to say is that if direction cosines of AB are positive, then direction cosines of PA will be negative. Because you see that what are direction cosines? Direction cosines are cos of direction angles. And what are direction angles? Direction angles are the angles meeting with the positive x-axis. But if it is in the fifth, sixth, seventh, or eighth octant, then I'll have negative angles. From the positive x-axis, I'll have in the clockwise direction, so it will be negative, and that will give me a negative answer. Okay, so one. Yes, we'll use it in the questions later. See this. Angle between the two lines. With the angle between the two lines, if you know, please note we are talking everything we are talking about only the three dimension. So in a three dimension, if I have two lines and I know their direction cosines, L1, M1, N1, L2, M2, N2, then I can easily find their cos. Cos of theta, what is that? L1, L2 plus M1, M2 plus N1, N2. All right. So, L1, L2 plus M1, M2 plus N1, N2. Okay. But even if you, instead of direction cosines, they have given us direction ratios, then also you can find angle if direction ratios of these lines are A1, B1, C1 and A2, B2, C2. Then, acha, you can write this formula by yourself also, because a formula that you know in terms of direction cosines, but direction ratios are given. I know how to convert direction ratios into the direction cosines. How? I will divide each one of the component over here by a1 square plus b1 square plus c1 square, and each component over here I'll divide by a2 square plus b2 square plus c2 square. So what will be L1, L2? L1, L2 will be A1 divided by that root part and A2 divided by that root part. So I'll multiply. When I'll multiply, I'll get A1, A2 divided by square root of A1 square plus B1 square plus C1 square plus under root of A2 square plus B2 square plus C2 square. What will be M1 and 2 plus M1 M2? But in M1 M2, B1 B2 will be multiplied and the root part will be still same. So that's why I have taken the LCM, because all the denominators are going to be same. Numerator is going to be A1 A2 plus B1 B2 plus C1 C2. All right. Yes, in denominator C2 square. Oh, yes, sorry. That is in multiplication. C2 square. All right. So this is a formula when you have direction ratios instead of direction cosines. Acha. Now, what is the condition? What is the condition of perpendicular lines? What is the condition of perpendicular lines? If you are talking about this formula, then it will be cos 90, angles between them cos 90, but cos 90 is 0. In that case, L1 L2 plus M1 M2 plus N1 N2 is equals to 0. Okay. So in terms of direction cosines, if you have perpendicular lines, then L2 plus M1 M2 plus N1 N2 is going to be 0. In case of direction ratios, cos theta, here cos 90 is again 0, but here I have a fraction is 0 if and only if its numerator is 0. So here also a same situation, A1 A2 plus B1 B2 plus C1 C2 is equals to 0. Right? Condition of parallel lines. Condition of parallel lines. In parallel lines, cos 0. Cos 0 is 1. So cos 0. Yes. So condition of parallel lines we will not calculate from here. Just see that if I have parallel lines, then the angle with the x-axis, y-axis and z-axis of both the lines will be same, right? So uh, if alpha, beta, gamma are same for both of the lines, because see what we do, if none of these lines are passing through the origin, then I make them passing through the origin. I take a parallel line parallel to that and passing through the origin. So basically both the lines will become exactly same. So alpha, beta, gamma are same. Cos alpha, cos beta, cos gamma are same. L1, M1, N1 and L2, M2, N2 are exactly same. Instead of writing that L1 is equals to L2, M1 is equals to L2, I can write this in this form also. I can write L1 by M1, L2 is equals to M1 by M2, because they are same, no? So all of them are equals to what? 1. L1 is equals to L2, M1 is equals to M2, N1 is equals to N2. Okay. But if I have direction ratios in my hand, then their ratios will be just same. Their ratios will be just same because So I have parallel lines. They also have L1, M1, N1 direction cosine, and they also have L1, M1, N1. But when it comes to direction ratios, it may happen that I have obtained the direction ratio of line 1 by multiplying A, and I have obtained the direction ratio of line 2 by multiplying B. So the direction ratios are different, but the ratios are still same. A L1 divided by B L1 will be equals to A M1 divided by B L1, B M1, A N1 divided by B N1. And all of them are equal to some constant. Here in this case, A by B. Okay. So here direction ratios are A1 by A2. The direction ratios are proportional. Okay. That can be equals to any constant. There is a very important identity. It will be used throughout the analytic geometry. You can try to prove also. It is just the using of some identity, solve left hand side and right hand side, you will get it. It is known as Lagrange's identity. Okay. Lagrange's identity. It's important to mention it here so that every time I use, I can just refer to this. Okay? You should know that. What does it says? It says P1 square plus Q1 square plus R1 square multiplied by P2 square plus Q2 square plus R2 square minus, here P1, Q1, R1 and P2, Q2, R2 are just any real number, not direction, cosine, direction ratio, nothing like that. Any real numbers. Okay. Minus P1, P2 plus R1, R2 plus Q1, Q2 plus R1, R2 whole square plus R1, R2 whole square is equals to there is a pattern. You can actually take the help of this. Write down P1, Q1, R1 and again P1. Here also P2, Q2, R2 and again P2. Okay, and there is a simple pattern. P1, Q2 minus Q1, P2. P1, Q2 minus Q1, P2 whole square. That whole square is saving you from the fact that you can multiply any of them first, any of them later, plus Q1 R2 minus R1 Q2. Q1 R2 minus R1 Q2 whole square plus, and the last one will be R1 P2 minus P1 R2 whole square. This is the Lagrange's identity. You can see there are basic identities used: a minus b whole square, a minus b whole square, a plus b plus c whole square. If you want to verify, you can verify. Left hand side will come out to be equals to right hand side. You need to solve both of them here. Okay, let's see. Okay, before this question, although straight line is our topic, but just to attempt this question, let me tell you a small point about the straight line, which is if line, acha, beta, what is the equation of line in two dimension? In class 9th, class 8th, this is taught linear equation in two variables. 2x plus 3y is equals to 5. It represents a line, right? It has two variables, both have linear powers. So it represents a line, but it represents a line in two dimension. Okay, we used to make that table, right? X, Y, substitute x is equals to 0, find out y, substitute y is equals to 0, find out x. And here you have 2 points, 0 comma something, something comma 0, and join them, that will make a line. Simple. But how do I represent a line in three dimension? You cannot increase a number of variable here. It's not like you just add plus 4z is equals to 5. Now it is representing a line. No, it is representing a plane. If you increase, if you follow the pattern of linear equation in two variable in two dimension and you want to extend it to the three dimension, you can't do that by just adding a variable. That actually represent a plane in the three dimension, not line. Okay, so there are two ways to represent line. I am talking about one of them right now. Okay, this is called symmetrical form of equation of line. So to get to the equation of line, obviously I need some information. For example, in two dimension, if I give you slope m and if I give you 1 point on the line x1 comma y1, then you can find the equation of line. So that is called slope point form. If I give you 2 points on the line, that is called 2 point form. You can find the equation. So similarly, here also I need some information to write down the equation of line. If line L passes through, if line L passes through point, so here a point is given x1, y1, z1, and other information is direction ratios of the line. And direction ratios are A, B, C. Then equation of line is given as, please see, x minus x1 by A is equals to y minus y1 by B is equals to z minus z1 by C. I hope it rings some bells. This kind of equation you have seen. So what is this x1, y1, z1? That is a point on that line, x1, y1, z1. And A, B, C are the direction cosines of that, direction ratio of that line. Direction ratio A, B, C. If I have these two informations, I can write the equation of line. Let's see. So now let's see example, question number 1. Question number 1. They are talking about two lines. What are the two lines given? Two lines are x minus 1 by 1 is equals to, see, it is not written in the form of the equation that we have seen here. It is y minus y1 by b. So you will make it. You will make it in the form of y minus y1 by b. So how? 2 first of all take common. So if I take 2 common, I'll get y plus 3 by 2. So it is basically y minus minus 3 by 2. Right? And where does that 2 goes? 2 goes in the denominator. So we have 3 already. So 3 divided by 2. Okay, that 2 that was here, I have taken that in denominator here. So now it looks like y minus y1 by b1. So is equals to, again here, z minus minus 5 by 2. So for the first line, what is the point on the line? 1 minus 3 by 2 and minus 5. And what are the direction ratios of this line? 1, 3 by 2 and 2. Also note, if you are dealing with a equation of a line like this and you said that okay, these are the direction ratios, but it is satisfying the relation L square plus m square plus n square is equals to 1, then they will actually become direction cosines. But in general that is not true. Okay, for example, over here also the sum is not coming out to be 1. So these are only direction ratios, not direction cosines. Please note, every result that I write for direction ratios, you can easily replace that by direction cosines. But the converse is not true. So basically, every direction cosine is direction ratio, can be considered as direction ratio, but direction ratios are not direction cosines. Are not direction cosines. Why I'm saying that direction cosine is a direction ratio? Because direction ratio is something that I obtained by multiplying them by a non-zero constant. 1 is also a non-zero constant. So if I multiply 1 with each of them, that becomes direction ratio. And actually that is LMN. Okay. So direction ratios are, direction cosines are just direction ratio. So every direction ratio result can be converted into direction cosine, but not the converse. If I'm writing a result with respect to direction cosine, that is not true for direction ratio. All right. So direction ratios of that line. This first line I know. So A1, B1, C1 is 1, 3 by 2, 2. I'm not writing the point because I don't need the point on the line, because what I have to find angle between them. For angle, I want direction ratios of both of the lines. That will do my job. And what is the other line? Other line is x minus 2 by 3 is equals to y minus 1 divided by minus 2 is equals to z minus 2 divided by 0. 0 in the denominator is allowed here because it is not actually representing division, it is representing the direction ratios. Okay, this is just the form in which we write it. Okay. Chalo. So what is A2, B2, C2? 3 minus 2, 0. Just apply formula. Cos theta is A1, A2. Let's multiply. A1, A2 plus B1, B2 plus C1, C2. Yes. Divided by whatever it is. Divided by the root of A1 square plus A2 square plus A1 square plus B1 square plus C1 square, A2 square plus C2 square, B2 square plus C2 square. But the answer is coming out to be 0 because the numerator is coming out to be 0. Okay. So what is theta? Theta is 90 degree. The lines are perpendicular. Okay. No, beta. Please check. Please check. I am pretty sure that I did upload in the last class. In last class, in the yes, it is there. See, linear algebra lecture 7, then analytic geometry PN Chatterjee, and then analytic geometry lecture 1. Just below the video, just see there are 3 notes. PN Chatterjee I have uploaded. Yes, obviously. Yes. Okay. Next we have hmm, with these two questions we'll finish, and these two questions actually are the core of the direction ratio direction cosines. Means the question, if the questions can be asked upon direction cosines direction ratios, it will definitely not be angle finding formula or this, it will be questions like this. Okay, so before that, let's see one more thing. Direction ratio, if it is not given to you, then you can find by one more information. What is that? Just a second. Okay, so direction ratios you can actually find. Direction ratios you can find by 2 points on the line. Means direction ratio directly is not given to you. What is given? There is a line and you are provided with 2 points on it. X1, Y1, Z1 and X2, Y2, Z2. Then simple, how can you find direction ratio? Direction ratio of a line PQ is simply x2 minus x1, y2 minus y1, and z2 minus z1. Look at this question. Question number 2. If A, B, C are if A, B, C are minus 1, 3, comma 2, 2, comma 3, comma 5, and 3, comma 5, comma minus 2 respectively. Find all angles of triangle ABC. So what they have given? A, B, C coordinates are given to you. A is given to be 2, 3, sorry, minus 1, 3, 2. B is given to be 2, 3, 5. And C is given to be 3, 5, and minus 2. These are the 3 points given. Find all the angles. How can you find angle A, let's say? This is basically the angle between the two lines. Angle between the two lines whose direction ratios are given. How will you find direction ratio of AB? From point A and B. Minus 1, minus 2, 3 minus 3, and 2 minus 5 are the direction ratios of AB. Similarly, you will find the direction ratio of AC. Similarly, you will find the direction ratio of BC. When you have direction ratios of all three lines, you have to apply the formula. Answer is going to be, try this question, cos inverse 3 by 2 root 10, 90 degree, and cos inverse 3 by 2 root 2. These are the answers. Just try. Now, let's see this question. There is only one question number 3. Question number 3. There's only one kind of trick for these kind of questions, and also note beta in PN Chatterjee, at least the PDF that I have uploaded, in that PDF, the questions, some questions are marked star and some questions are marked double star. You cannot leave these questions. All right, for example, this question particularly, you can see a star is marked here. Okay, so in the whole PDF, star or double star questions are there. You cannot leave them. And my suggestion would be, because this is the first time if you are going through the analytic geometry, you'll not be able to complete every question. So how you will select the questions? Star and double star. Okay. Yes, sometimes it will happen that you are not able to do it. Then you can see a non-star questions, because usually there is a hint in the previous questions. Okay, or you can discuss with me. But these questions you should not leave. Find the direction cosines LMN of two lines which are connected by the relation this. So basically you have to find LMN and two equations are given. Okay. But when I have three variables, I at least need three equations, number one. Number two, we are usually used to solving three variables in three linear equation. One of them is not even linear equation. Okay, so how to proceed? See, from the first relation, find out any of your direction cosine. I'll find out L. L is 5m minus 3n. Okay. Now, use it in the second equation. 7 times L square plus 5m square minus 3n square is equals to 0. Solve. 725m square plus 9n square minus 40 30mn plus 5m square minus 3n square is equals to 0. So it turns out to be, and here is a 5, here is a, so 5 common, 5 plus 1 6, 6 multiplied by 35. No, 5 बाहर रहेगा, तो it is 7 times this ना, 35 3 75 180 m square, then we have 63 minus 3 plus 60 n square and minus 210 mn is equals to 0. You can make this equation, you can convert this equation. First of all, take common. I can take 60 common. No, 60 will not be taken common from here. So at least 6, 30 common I can take. 30 I can take common. So 6m square plus 2n square minus 7 mn. Okay, now this equation you can consider it as a quadratic equation in m or quadratic equation in n, whatever you want. So if I consider this as quadratic equation in m, so how will it look like? Coefficient of m square, coefficient of m, and the constant, because I'm considering my m as a variable here, n is as a constant. So solve it, apply quadratic formula. M is equals to minus b plus minus square root of b square minus 448 n square divided by 12. So m is equals to 7n plus minus square root of n square, which is n, divided by 12. So we get m is equals to 8n by 12, which is 2n by 3, or 6n by 12, which is n by 2. Therefore, m by n is equals to 2 by 3, or m by n is equals to 1 by 2. From here, you can find out L also. What was L? In equation 1, L was 5m minus 3n. So, this is a basic fraction result. When we deal with fractions, a a1 divided by b1, when it is equals to c1, a by b is equals to c by d. Then you can write down that as equals to some constant times a1, a, plus some other constant times c. But this kind of linear combination, I can say that it's a linear combination of these two, a and c, k1 times a plus k2 times c. This same linear combination you have to do in the denominator also, k1b plus k2d. Okay, so what is that k1 k2 I require? I require it to be 5m minus 3n. So what I'll do, So this can be written as m by 2 is equals to n by 3, and now I'll make it as 5m minus 3n. So that I have to do in the denominator also. 5 times 2 minus 3 times 3. Or for this one it is m by 1 is equals to n by 2. So it is also equals to 5m minus 3n divided by 5 times 1 minus 3 times 2. Now it implies m by 2 is equals to n by 3 is equals to 5m minus 3n divided by 1. Here m by 1 is equals to n by 2 is equals to 5m minus 3n divided by minus 1. Okay, which is nothing but L. So I have m by 2 is equals to n by 3 is equals to L by 1, or m by 1 is equals to n by 2 is equals to L by minus 1. Now you cannot say that you got the value of lmn, because lmn are not 1 2 3, they are proportional to 1 2 3. So if your direction ratios are proportional to some other constant, those constants are nothing but direction ratios. Why? Because let's say this is k. So let's say this is k. L, obviously why, there's one more reason they can't be direction ratios, because L square plus m square plus n square, 1 square plus 2 square plus 3 square is not going to be 1. Okay, so so why these 1 2 3? Let me write this first. It implies L by 1, m by 2, n by 3 equals to k, or L by minus 1, m by 1, n by 2 is equals to some lambda. Okay, so why I'm saying that 1 2 3 are direction ratios? Because if you find out, if you equate first and this last and find out the value of 1, what is it? 1 will be equal to, this is not the part of the question. This is not the part of the question. I'm just trying to show you that why 1 2 3 are direction ratios. Because when you find out 1 by equating this first and the last, then 1 will be equals to 1 by k times L. Similarly, 2 will be equals to 1 by k times m, and 3 will be equals to 1 by k times n. You are multiplying same constant with all three direction ratios. Obviously, the resultant is you are multiplying it with direction cosines. So obviously, the results are direction ratios. That is the definition of direction ratios. Okay. Now, how you will find out direction cosine from direction ratio? Simple. Simple. How? This L by 1 is m by 2 is n by 3 is equals to plus minus 1 divided by, what is that constant? Constant we have calculated in general. Right here. This was actually, if direction ratios are given, you can convert it into direction cosines. How? By dividing them by a square plus b square plus c square root. That's what exactly I'm doing here. So that is equals to plus minus 1 upon 1 square 1 plus 2 square 4 plus 3 square 9. So it is plus minus 1 by root of 14. Okay. So what is the first set of direction cosines you are getting? You are getting plus minus 1 by root 14, plus minus 2 by root 14, and plus minus 3 by root 14. Okay. Direction ratios, you have divided by root of a square plus b square plus c square. It is converted into direction cosines. Same thing you can do over here also. And similarly, L2, M2, N2 are plus minus 1 upon 1 square is 1, 1 square is 1, 2 square is 4, 4, 5, 6. Root 6 plus minus plus minus 1 by root 6 and plus minus 2 by root 6. Now, these are the answers. Question is done. Why we have two choices of L1, M1 and L means direction cosines. Okay. Basically, the relation that was given, that was a quadratic relation. So obviously, I can have two possibilities. So there are two set of direction cosines, and in fact, if you see closely, okay, there was a minus one, so it will be minus plus. So actually, there are four choices. One with all of them plus, one with all of them minus. Here also one with minus plus plus, then plus minus minus. So there are four choices because of that plus minus. Otherwise, in general, if I only take the positive values, then I have two choices of this element, which are satisfying both the relations. Next. See this question, question number 4, and it's a double star question. Look at this, double star. Okay, show that the straight line whose direction cosines are given by these equations are perpendicular if this happens and parallel if this happens. Okay, so show that the straight line whose direction cosines are given by this relation. So direction cosines are LMN. They satisfy these two relations. I can find LMN. We just have done it. So let's find out. Let's find out. Start doing the calculation. First of all, I'll calculate L from here and I'll substitute there. Start. Give me a minute, please. Done. So, you'll find out L from one of this relation. This is V m plus W n divided by U. That's your first relation. You'll use it in your second relation, which is A minus Vm plus Wn divided by U whole square plus bm square plus cn square equals to 0. I'll consider it as a quadratic equation in n. So for that, let's collect coefficient of m square. So it is a v square by u square plus b m square plus a w square divided by u square plus c n square. That is actually the complete constant, and then the coefficient of m. Coefficient of m is 2 v w n a divided by u. N. Okay. Now it's a quadratic in m. Okay. If such kind of thing happens, because now it is going to be a very cumbersome equation. So what we can do, I can avoid using n here. Now how? Instead of considering equation in m square, I can consider equation in m by n square, means m by n. I can consider equation in m by n. Just because of the complexity of this, I can see that it will not be a good choice to start with by applying the quadratic formula. So I'll get a very complex equations. So to avoid that, I can get rid of one more variable, that is n. How? Consider this as a mm, quadratic in m by n, because see earlier also when you considered it in terms of m, answer was for m by n. So if I even consider directly in that question in terms of m by n, then I'll get two values directly of m by n. So let's consider it in m by n. So to do that, this is m square, this is n square. So basically, let's divide by n square throughout. So a v square divided by u square plus b. This will be m by n square plus. If I divide this by n square, the n from here will be gone. Wa divided by u m by n. And if I divide this by n square, then this n square is gone. So it is w square by u square plus c is equals to 0. This is my second equation. Now, the question didn't say that we have to find the element. That was actually the target in the last question. Find the direction cosines element. Here, the question doesn't say that you have to find it. They are just saying that whatever the element is, whatever the element are of those two lines are perpendicular if this happens, parallel if this happens. Okay. So let us assume that I already have the equations. Like let us say I already have the roots. Let m1 by n1, because it's a quadratic equation, so I'll have two roots. So let m1 by n1 and m2 by n2 are are two roots of equation 2. Acha, what will happen now? It may be a bit of a issue or a bit of a complexity can be arrived if I find now the roots, but I can comment on sum of roots and product of roots. Now, how that is going to help us? Because whatever the case is, whether it is perpendicular line or parallel line, I know the relation are between L1. If it is perpendicular, then L1 L2 plus M1 M2 plus N1 N2 has to be 0, right? That can only be arrived in the situation if I do the product, because I don't want L1 and L2 separately, but I want L1 L2, I want M1 M2, I want N1 N2. Okay, to arrive that situation, just let's try with the product. Maybe that can help. The product of roots would be, yes, everybody remember? If I have ax square plus bx plus c is equals to 0, I'll generalize this result also. Please observe. Uh, Sum of roots alpha plus beta is minus, it always starts with minus and minus b by a, right? And then alpha beta is just c by a, है ना? C by a. You can generalize this result also. I just did this in, I think, the last class I was teaching. See, sum of roots, product of root. This can be useful for higher dimensions also. There is a small pattern I have to observe. If roots are alpha beta, then this is the result. We also remember that. For alpha beta gamma, actually it is actually sum of the roots taken one at a time. It is actually sum of roots taken two at a time, but there are only two roots, so we have stopped here. Here, how does it work? Sum of roots taken one at a time, alpha beta gamma minus b by a. Again, the it starts always with the negative sign, minus b by a, then plus c by a, and then minus d by a with the alternate sign. Okay, so sum of the roots taken two at a time, like product, sum product. Sum of the product of the roots taken two at a time, sum of the product of the root taken one at a time, sum of the product of the root taken three at a time, but there are only three, so alpha beta gamma. Minus b by a, c by a, and minus d by a. For four roots, for biquadratic, it will be minus b by a plus c by a minus d by a plus e by a. If roots are alpha, beta, gamma, delta, then these are the observations. Sum of the roots, sum of the product of roots taken one at a time, sum of the product of roots taken two at a time, sum of the product of root taken three at a time, taken four at a time. You can generalize for n roots as well. Anyways, so product of the root is c by a, c by a. So what is that? So what is a product? Product, I have assumed m1 by n1 multiply m2 by n2. So that will give us, yes, c by a omega, not omega, w square by u square plus c, and c by a divided by a v square divided by u square plus b. Okay, so how can I handle that? We can simplify it. M1 M2 divided by N1 N2 is equals to A W square plus C U square divided by A V square plus B U square. That means M1 M2 divided by A W square plus C U square, that is equals to N1 N2 divided by a v square plus b u square. Now, from here, either you repeat everything now, either you repeat everything, because why I'm getting the relation of m1 m2 n1 n2, because in the beginning I found n. So now, in order to get L1 L2 part, either you restart and you find m from here and then repeat all the calculations, which is again a extra job to do. Instead of that, you can write it as L1 L2 divided by, just follow the symmetry, means just try to see that what symmetry it has from m1 m2 and n1 n2, because it will be same for l1 l2. So sometimes it's because in this particular case it is not just obviously strikes. For example, if this would have been a, if this would have been b, then the obviously answer will be c over here. Okay, but it is not that simple. So what you can do is you can write down all the constant parts. Basically what they have used a b c u v w. Hmm? These are the six constants they are using. So write down a B C U V W three times, है ना? Obviously, it's your rough part. A B C U V W and A B C U V W. Okay. So among these six constants, what do we have in the denominator here? It's A W square minus C U square. Here it is a v square minus b u square. So I hope that you're getting what should be the denominator of L1, L2. Okay, so it would be b and c. So b w square minus plus c v square. It would be b w square plus c v square. And you'll write the reason that we have written it by symmetry. We have observed the symmetry, and that's how we have written it. This is only the one question I'm doing. There are many questions of the same type, so please do the practice. And okay, this is done. So now how it is helping us? It is actually the first part is done now. How? If I equate it with, let's say, some k, then you have the value of L1 L2, M1 M2, N1 N2. Just multiply by k, equate it with the last k. Therefore, starts from, therefore L1 L2 is k times bw square plus cv square. M1 M2 is k times aw square plus cu square. And N1 N2 is k times av square plus bu square. Okay. Number one. Now, if lines are perpendicular, then L1 L2 plus M1 M2, we have to prove that lines are perpendicular if that condition satisfies, if that condition holds. Okay, so I have to prove this condition. If lines are perpendicular, then L1 L2 plus M1 M2 plus N1 N2 is equals to 0, which implies, just substitute the values, k times b w square plus cv square plus k times aw square plus cu square plus k times the last one is a v square plus b u square is equals to 0. K gone, taking common, taking to the right hand side, k is gone, and I can just mold it in the form that I want. I want u square, v square, w square common here. So let's take u square common. So if I take u square common, I'll get c plus b, so b plus c, plus v square common, I'll get c and a, so a plus c, And if I get w square common, I'll get a plus b is equals to 0, hence proved. Okay. Number two, if lines are parallel, if lines are parallel, what will happen if lines are parallel? Let's go back to equation number two. So LM are direction cosines, not direction ratios. Two parallel lines have same direction cosines. They may have different direction ratios which are proportional to each other, but when it comes to direction cosine of two parallel lines are exactly same. So in that situation, what will be the root of this equation? What are the possible values of m1 and by n1 and m2 by n2? They are same. They are exactly same. They are not proportionate. They are exactly same because they are direction cosines. So that means I'm talking about a situation in which this equation is giving me a equal root. So when what condition do we have? A quadratic equation has equal roots. The nature of root is uh, um, equal and real if and only if discriminant is zero. If and only if discriminant is zero. So if lines are parallel, then equation 2, then the equation 2 have equal roots, which implies discriminant is equals to 0. And what is the discriminant? B square. B square is, this is B. So 2AVW, it implies 2AVW divided by U square. Square is equals to 4AC. Beta, A is AW square plus CU square by U square. And C is AV square plus BU square divided by U square. Solve it. You will get that required condition. U square by A plus V square by B plus W square by C is equals to 0. Okay. Three cases, beta. Uh, Real and distinct roots, equal roots, and imaginary roots. No, cannot be any number. It has to be a real number. The results are not true for the complex numbers. Roots of ax square plus bx plus c is equals to 0, where a, b, c are real numbers and a is non-zero, are number one, distinct and real if b square minus, if d discriminant is b square minus 4ac is greater than 0. Second, equal and real if d is equals to 0. And third, imaginary if d is less than 0. Okay, this is important. Let's do one more question. Okay, then we'll finish it. Question number 5. Find, I'll give you 5 minutes. Okay, so try. Whatever you have learned from the last two questions, just try to apply it here. Find acute angle between the lines whose direction cosines are given by the relation as L plus M plus N is equals to 0 and L square plus M square minus N square is equals to 0. It's an easy question. Try. Done? Shut up. Let's try. Okay, so I hope there is a small bit of a problem here in this question. So if I find L here, which is minus M minus N, and I substitute, so I substitute it here, I'll get M plus N whole square, one and the same thing, plus M square minus N square is equals to 0. So M square plus N square plus 2mn minus m square, sorry, plus m square minus n square equals to 0. This and this cancels. 2m square plus 2mn is equals to 0. If I consider this, 2 is gone, and if I consider as a equation in terms of m, so it is m square plus n times m is equals to 0. M common, m plus n is equals to 0. So m is equals to 0 and m is equals to minus n. These are the two possibilities. So what is the value of m by n? Now this is important. From, even if I consider this as quadratic in m, then my job is to find m by n in the two roots. In the first one, in the second one, m by n is minus 1, simply. But over here, if m is 0, better, see, this is not actually what I can say. These calculations are not for just simple numbers, but these kind of representations are possible when I'm dealing with direction cosines and direction ratios. Okay, what I'm talking about here is 0. Actually, I will take that equals to 1. So, just a second. See, I can write it as 0 times n. Okay, this part I can do for any two real numbers as well. But the next, now, m by n is 0 by 1. This is also possible. Okay, no problem. So, it is minus 1 by 1 and 0 by 1. These are the two answers. So, first one, case 1 is, or just take it like this. So, m by n is 0 by 1, which 0 by 1, and m by n is minus 1 by 1. After that, we find m and n in the numerator. We write n and m in the numerator, and this is not allowed for any common numbers. So, but here I'm dealing with direction cosine, so I can say that actually it is proportional to 0, which will represent its direction ratios. So m by 0 is equals to n by 1, and how can I make L from here? Minus m minus n. So minus m minus n divided by minus 0 minus 1. Here also m by minus 1 is equals to n by 1 is equals to minus m minus n divided by minus of minus 1 minus 1. So it is m, let me write L first, L divided by minus 1, m divided by 0, n divided by 1, and the next possibility is L by minus 1 plus 1, L by 0, m by minus 1, and n by 1. The denominators, now I'm not going to go through all of that to explain that why they are direction ratios. The numbers which are proportional to LMN are direction ratios. Therefore, direction ratios of two lines of given lines of given two lines are minus 1, 0, 1, which can be considered as A1, B1, C1, and 0, minus 1, 1, which can be considered as A2, B2, C2. What they are asking? Acute angle between the lines. We have the formula of angle. We have the formula of angle, cos theta. When it is direction ratio, it is A1, A2 plus B1, B2 plus C1, C2 divided by square root of A1 square plus B1 square plus C1 square root of A2 square plus B2 square plus C2 square. Okay, so cos theta is equals to, find out, substitute all the values, do the calculation. This is going to be 1 by 2. So theta is going to be 60 degree, which is pi by 3, which is acute. But actually the question, if the question is asking about the obtuse angle, So first of all, what is the meaning? Why the angle is sometimes acute and sometimes acute? Because beta, when two lines intersect each other and they are not perpendicular to each other, then there are actually four angles between them, in which two of them are obviously same. A and B are same, and you can see A and B are acute. So if the question would be asking about find the obtuse angle, then you will end up having this 60 degree. Then how will you find out the C linear pair? Okay, so if the question is obtuse angle, then you will find obtuse angle. This is acute. So obtuse angle you will find by 180 minus 60. Okay, that will be your obtuse angle. All right, that's it. That's it in the direction ratios, direction cosines, and if I'm correct, this is the. Let's see why the lectures are still announcing linear algebra. Okay, I'm talking about the PDF that I have uploaded, the second chapter, direction, cosines, and projections. है ना? So projection is something that we need to discuss. We haven't discussed that. But direction, cosines, and the system of the coordinate is the first chapter. So please complete all the questions from here. Okay. In the first chapter, please don't pick your pen and start writing anything. No, just read everything. Just see every question. You know, just believe in yourself. I know I can do the first every question in the first chapter. Not every time you have to write it. Okay, some things you should leave it to this also. So believe that it works. Okay, and if you have chosen mathematics, so it actually works. So first chapter, just go through it. No need to write anything. Okay, try to complete first chapter without lifting your pen. That's it. Second chapter, try every question, especially the star marked question, not the projection part. All right, but projection we have to do that. That is important. All right. Next we have. There are some good questions I can see there. I think there are 20. Yes, 20 questions are there. And we have some extra questions in the miscellaneous. Seven examples in the miscellaneous. Please try these questions. Try out, okay? All right. Let's come back to the next topic. We are starting with the planes. Okay, I don't understand your question. But a cos theta is 0 if L1 L2 plus N1 M2 plus N1 N2 is 0. And that will happen if and cos theta is equal to 0 implies theta is 90 degree. I think I'm not able to understand the question. Okay. So here we were doing. Let me use a different naming criteria. Otherwise, it is confusing. Direction. So this is not lecture 1, but it is actually lecture 1 of plane. I'm just using a different naming criteria. Okay. All right. Okay. As I said just now in the last lecture, that if you increase the number of variable, if you want to extend your equation of line in the equation of from equation of line in 2 dimension to equation of line in 3 dimension, you don't just increase a variable. It's not, if equation of line in 2 dimension is ax plus by is equals to 0, it will not be ax plus by plus cz plus d equals to 0 in 3 dimension. That actually represent a plane. Okay, so I think that point we are clear with, है ना? This is good over here also, I guess. White will not work, I guess. White is also fine. Okay. So ax plus by plus c is equals to 0. This is line in 2D. This is line in 2D. And if I increase a variable ax plus by plus z plus d is equals to 0, that is plane in 3D. Obviously, the concept of plane is in 3D only. The concept of line is in both 2D and 3D. But concept of plane is in 3D only. Plane. In 3D, it represent plane. It does not represent a line. Okay. Now, when I represent a line, actually, whether it is 2 dimension or 3 dimension, it is very easy to represent. Okay. And when I represent a line, I make these arrows. What does that arrow simplify? That it is an infinite length line. It's not, it does not have a finite length. A line having the finite length is line segment, right? So these arrows are actually telling me that the line divides my whole plane into two parts, one above the line, one below the line, or one on the left side, one on the right side, whatever you say. But and there are only three situations possible: on one side of the line, on the other side of the line. You can't say that there is a point which is neither on in both of in none of them. If I draw any line, for example this line, where it is on the line, because line is infinite. Line is infinite in length. Okay, so every point will be either on the line, on the left side, on one part of the line, or the second part of the line. Three cases are possible. But making these arrows actually help me to understand the concept of line very easily. But when it comes to plane and I draw something like this, usually my mind says that it's a rectangle, it is of finite area. But instead of rectangle, when I call it as a plane, beta, it is not of finite area. I cannot represent arrow over here to represent that actually it is not it is not of finite length or breadth. It goes on from all the four sides. Just imagine a small rectangle and now just imagine it becoming huge. From all the direction it is extended to the infinity. So basically it is separating the whole space into two parts, one behind that plane, one above that plane. Getting the point? So whenever I draw a plane, you will not imagine it as a rectangle or as a parallelogram or anything. It is actually uh, in infinite directions. From all the four sides, I can extend it to all of them. I cannot make arrows over here. You have to represent this. When I say plane, it is of infinite area. Okay, I hope I'm clear here. Now, one more thing. We haven't done projection over here. So let me just define once what is projection. You can try question of projection also from the second chapter. That's easy. I'm already defining it. Projection. Projection we can find. Projection we can find of a point on a line. How can I find projection of a point on a line? So this is a point P and this is a line. Okay. This is line AB. So how to take projection of a point on a line? Very simple. You just drop a perpendicular. Just drop a perpendicular. So if I drop a perpendicular from the point on the line, foot of the perpendicular is your projection. Projection of a line would be a line, projection of a point will be a point, projection of a plane will be a plane. So projection of a point will be a point. And what is that point? N, foot of the perpendicular. The projection of a point P on line AB is actually point N on AB such that PN is perpendicular to AB. Perpendicular to AB. Okay. Acha. We are talking about projection, so let's discuss one more thing here. What about projection of a line on a line? Or let me take line segment first. What will be the projection of a line segment over a line? Over a line. Again, very simple. No, no. Again, a projection of a point is a point. A projection of a line segment is a line segment. Projection of a line is a line. Projection of a plane is a plane. Okay. So projection, when I use the word projection, I have to tell two things. You're taking the projection of what? You're taking the projection where. Okay. For which I need the projection and I need the projection where. So I need projection of AB on line L. What does that mean? How will I obtain the projection? That is again very simple. Take the end points of A and B and drop the perpendicular. So from A, this is the perpendicular. From B, this is the perpendicular. Let it be M, N. Mn is nothing but your projection. Okay, here Mn is projection of AB on line L. On line L. Okay, now let's see. What is the definition of a plane? A plane is defined as a surface which is such that the line joining any 2 points on it lies completely on it or lies wholly on it. That means if I take 2 points on a plane, right, then I join the line. Then that line is completely on this surface. This is a plane. This will not happen for any other surface. For example, sphere. Sphere is a surface. This is a sphere. Okay, everybody understands sphere is like a ball. So in the sphere, if I take 2 points, 2 points where? On the surface of the sphere. So let me take 1 point to be, let's say here, okay, on the front side and a point on the back side. Both are on the surface. But when I join them by a line, is this line? In actual, this is also a line, not just a line segment. Line. The complete line will be on my surface. But here, the complete line is definitely not on my surface. There are only 2 points which is common to my line and the surface. Those A and B. Right? Okay. So, general equation. What is a general equation of a plane? We already have discussed it. Let me write general equation of a plane. That would be ax plus by plus cz plus d is equals to 0. Why it is the equation? If it is equation of the plane, then it satisfies my definition of plane. What is the definition of plane? Definition of plane says that if you take 2 points on that surface, if this surface is plane, then let me take 2 points on this. Then let me take 2 points on this surface. So let xa, which is x1 y1 z1, plus and b, which is, okay, a and b are already used, so let me take them as p and q. X2 y2 z2 lie on uh, surface lie on surface given by equation 1. I'm not calling it as a plane actually because I'm proving that it's a plane. Lie on a surface given by equation 1. Now note, if 2 points are on it, that means it will satisfy the equation. Therefore, A times x1 plus b times y1 plus c times z1 plus d is equals to 0, and ax2 plus by2 plus cz2 plus d is equals to 0. Second and third. Okay. So what I have to prove? I have to prove that the complete line joining these 2 points is on that surface. So if I have a point x1, y1, z1, and I have another point x2, y2, z2, how can I prove that the complete line falls on that? Because see, if complete line falls on that surface, that means every point on the line is satisfying the equation. So in we don't do that in mathematics. We don't take every point. We take an arbitrary point. If it is true for that arbitrary point, it is true for all of them. So let me take any arbitrary point, anything, any random point from here. So how will I take that any random point? Section formula. I have written the section formula. You have to revise. Section formula. If this is P, this is Q, I can find this R if I assume that this is in the ratio 1 is to K. It can be outside also, it can be inside also. Section formula gives us the two formulas if your point R divides internally or externally. All right. So what is that point? That point is x1, 1. Let me take k is to 1. So x1 plus kx2 divided by k plus 1. Similarly, similarly, y1 plus k y2 divided by k plus 1 and z1 plus k z2 divided by k plus 1. This is the coordinate of r. Okay. So multiply equation 3 by k and add with equation 2. Add with equation 2. So what I'll get? See, if I multiply this by k and I'm adding it with this equation, so a common x1 plus kx2 b times y1 plus ky2 plus c times z1 plus kz2 plus d times 1 plus k is equals to 0. Dividing by 1 plus k, dividing by 1 plus k, it is x1 plus k. It is actually equation of that same surface, but instead of xyz, I have a point. That means this r point. Look at this. This is the equation of the surface. Ax plus by plus cz plus d, where x, y, z are a random point on that line. It implies a point r, which is x1 plus kx2 divided by 1 plus k, comma y1 plus ky2 divided by 1 plus k, comma z1 plus kz2 divided by 1 plus k, satisfy ax plus by plus cz plus d is equals to 0. Where this r point is nothing but an arbitrary point joining p and q. Where this r is an arbitrary, actually there is a property also in mathematics which is known as arbitrary property, and that is the base of mathematics. That if I prove that for a random element, for an arbitrary element, it is true for every such element. So where r is any arbitrary point, on line joining P and Q. From the section formula, this is P, this is Q, this is R, this is K is to 1, and you find out. That means if one point is satisfying, one point on the line joining them satisfying, that means all points on the line joining them are satisfied. That means all points joining, all points on line joining, on line joining P and Q, P and Q lie on AX, lie on AX plus BY plus CZ plus D is equals to 0. Hence, that surface is nothing but plane, because that surface is satisfying the definition of being the plane. So that's why this is equation of plane. Okay? So here I have proved that this is equation of plane. Okay. All right. Now, should I write with blue or the yellow one? Which do you think is not uh, putting much stress on the eyes? Blue or the yellow? Tell me. White, I think it's not a good choice. Blue? Okay. Okay. General equation of a plane through a given point. Okay, now this is interesting. What I have written is a general equation. I don't have any information. For example, if I write equation of a line, I have ax plus by plus c is equals to 0. Equation of a line, I don't know anything about this line. A can be anything, B can be anything, C can be anything. But when I have a information about a line, I can actually eliminate one of them. For example, if I give you only one information about this line, that 2 comma 3 actually passes through this line. 1 comma 2 is actually passing through that line. So you'll say, okay, if 1 comma 2 is passing through the line, then it will satisfy the equation. So a times 1 plus b times 2 plus c will be equals to 0. What you can do, you can find c from here. C will be minus of a plus 2b. So in your general equation, now instead of ax plus by plus c is equals to 0, you can write ax plus by minus a plus 2b is equals to 0. So this is now a line, this is representing a line passing through that 1 comma 2. This was a random line, any line, and the information that it is passing through the 1 comma 2, you have to tell it separately. You have to say that ax plus by plus c is equals to 0 is a line passing through 1 comma 2. But when I am saying ax plus by minus a plus 2b is equals to 0 is a line, I don't need to mention that 1 comma 2 passes through it. We'll figure it out from here. Okay, because you can substitute 1 and 2 and it will satisfy. Okay, so basically those two conditions I can merge to eliminate the number of variables. Now I don't need to find 3 variables. I need to find only 2 variables here. In my general equation of plane, I have 4 variables. If one condition or one information about the line, if one information about the line ax plus by plus c is equals to 0 is passing through 1 comma 2. One information about the line, one information can eliminate one constant here. I can get rid of either a or b or c, whatever you want. So a times 1 plus, it implies a times 1 plus b times 2 plus c is equals to 0, which implies c is equals to minus a minus 2b. Therefore line becomes ax plus by minus a minus 2b is equals to 0. Same kind of situation over here. If I have one given information about that plane, and what is that information? Plane passes through a point 1 a comma b comma c. So if it passes through a comma b comma c, I can try to eliminate one variable. I can try to eliminate one variable, and that would be d. I'll try to eliminate d from here. So how does that equation looks like? General equation of plane is what? Ax plus by plus cz plus d is equals to 0. First, that's the first equation. If it passes through, if it passes through a comma b comma c, then what? Then it will satisfy my equation. That means a times a plus b times b plus c times c plus d is equals to 0. Find out d from here. Or instead of finding d and substitute, I'll tell you one more trick to eliminate that d. Subtract. Subtract equation 2 from 1. That will also eliminate d. No? So subtract equation 2 from equation 1. From equation 1. So what I'll get? Capital A is common here. I'll get x minus a plus capital B is common, y minus b plus capital C is common, z minus c is equals to 0. This is the form of the equation that will be. This is the kind of form of an equation that will be useful, that you can use to directly write whenever there is the question says that a plane is passing through 1 comma 2 comma 3. You don't have to start from here, then this. Write down directly this result. Write down, then okay. Then I don't have to consider that it is ax plus by plus cz plus d. I'll write a times x minus 1 plus b times y minus 2 plus c times z minus 3 directly. But let me do it one more step. One more step I'm doing to just write it in the form of how general equation looks like. General equation looks like a coefficient of x plus coefficient of y plus coefficient of z, and then minus AA plus BB plus CC is equals to 0. Okay, this is not as useful as the first one. All right. Next, normal form of equation. No, before normal form of equation, if you remember and if you have seen, just give me a second. Yes. Now, if you have gone through that 11th, 12th NCRT, what I said, you might have observed that representing a plane in a three dimension, whatever concept, article, result, theorem, formulas, whatever we do, while making a plane, we don't make plane like this. We make it a triangle. Why so? Let's try to understand that. Okay. So This will be actually very useful for you throughout your just a second. Throughout your analytic geometry. It is it's this. ठीक है? You can just Google it, GeoGebra 3D. ठीक है? Also, please don't get used to it because obviously it should be just to clear your concepts. If you cannot imagine any uh, plane or after that we are going to study this cone cylinder, and in some situations you are stuck and you are not able to see the question that what from where the lines are coming from, where it's perpendicular and everything. So you can take the help of this to just get a clear picture in your mind, because when you get a clear picture in your mind, half of the question is still solved over there only. Okay, in analytic geometry that intuition is very important, that you can see the pictures around you. All right. So let me draw a plane over here. Okay. So I know the equation. Now I just have to type the equation. And one more thing, let's represent all the planes also, because you can see the red one and the orientation of these axes are exactly like the way I have taken in the beginning: x axis, y axis, and z axis. You can see the red one is x axis, green one is y axis, and z one is the blue one, z axis. So let me first represent all the planes. So all the planes are, I cannot write anything over here. Okay, so please focus. This, the gray part is xy plane, that is z is equals to 0. Then x is equals to 0 would be zy plane, that is actually the wall in front of you, zy plane. And then y is equals to 0. Then y is equals to 0. There goes your. I hope that you can see all the planes. So now once you can see all the planes, actually you can see all the 8 octants I was talking about in the beginning, in which the one you can see over here along the positive x-axis, positive y-axis, and positive z-axis, that is your first octant. That is where you're sitting. Remember? And then you have these four octant above that xy plane and 4 octant below the xy plane, below that gray plane. Gray is the xy plane, and you are right here in this part. Now let me draw a triangle over plane, not a triangle, plane. Plane is, if I represent in 2 dimension, I can represent it by any quadrilateral basically, है ना, a rectangle, square, or anything. But in general, you know that it is of infinite area. From all the sides it is extended to infinity. So if I take for example 2x plus 3y plus 5y plus 4 is equals to 0. It is representing a plane. Okay, just a second. Set. Let me give it a different color, red one. Okay, and let me give all the others as just the gray. So that that red part is highlighted. Yes. So the red one is your plane. Okay. You can see it is intersecting actually all the planes. But what portion does it represent on the first octet? You see, in the first octet, can you see that triangle? So basically, when a triangle is drawn to represent a plane, it is actually only the portion of the plane that is in the first octet, right? Because you see, the other part in the second octant, it obviously does not look like a triangle. In third octant also, I can say that okay, it's a triangle, you know, inverted triangle and upside down, and over here also. But in the first octant, it's exactly the triangle. Okay. One more point. In that first octant, can you see where does it intersect? What is the intersection point of that plane with the z-axis? Because I cannot write anything over here. So let me bring you back to. Yes, yes. We'll take the break after this, okay? This was the diagram, no? So this is representing your x-axis. This is representing your x-axis. This is representing your y-axis, positive y-axis, and this is representing your z-axis. Now the plane, where does it intersect your z? See, at 4. It intersect your x-axis at 2 and it intersect your y-axis at 3. Okay. So the 3 points you already know on the plane. What are those 3 points? 0, comma 0, comma 4, uh, 2, comma 0, comma 0, and here it is 0, comma 3, comma 0. When you had 1 point on the point, you eliminated one variable. If you have 3 points on your plane, you can eliminate 3 variables. Okay, so this is how we show the plane, and I'll not obviously show the xy plane and xz plane, yz plane. I'll only show this triangle, and now you know why. Okay, so let us discuss normal form. Before that, we take a break. All right, let's take a break. Push row, be happy. Don't need to be sad about it. है ना? चलो, let's have a break. Yes. Breaks over. Okay. Please see. The next is normal form of equation of a plane. So right now you have seen a general equation, ax plus by plus cz plus d is equals to 0, and that's the only equation we have seen so far. Now I'm applying some conditions. For example, here I have applied a condition that if it is passing through a point ABC, then I've started with the same equation and I get a different form of the equation where d is not there. D has gone. One constant was eliminated. Now I have normal form of equation of plane. So here given things will be different. What are these? Please see. We are going to start by considering a plane. This is z axis, y axis, and x axis. And let me show it using a. This is representing a plane ABC. Plane A, B, C. Okay, now you know why it's a triangle. It's just the only portion in the first octant. Okay. So, and that triangle that I have drawn is on the front side. Like this would be, this is on the back side. This portion. So origin, which is a point, is on the back side of a plane. From that point, if I have to draw a perpendicular to the plane, so it will be something like from O point, I am drawing a perpendicular on the plane. So it will look like this. This is perpendicular on the plane. Let me take a line on the plane. This is the line on the plane. It is in the back side of that triangle. Let me take this point, which is on the plane, as P. Okay. So I have considered OP as perpendicular perpendicular line from O perpendicular line from O to from O on ABC, on plane ABC. Okay. What will be coordinate of P? Let's talk about coordinate of P. Okay. So please observe, if this is perpendicular, then uh, when I'll not draw it over here. I'm drawing it separately. Okay. So this is z axis, this is y axis, and this is x axis. So here in the space, in the first octant, I have my point P. From P, I will drop a perpendicular to y. So it's a perpendicular. It's a tilted triangle, but it's a perpendicular triangle. This is O, P, and N, let's say. So you can see triangle OPN is right angle triangle. You can see that. What will be the angle of that line making with the y axis? What is this? This is with the positive y axis. This is beta. This is beta. Right? Direction angle, one of the direction angle. Same, this angle with the z, this line will make gamma with the z axis and alpha with the x axis. So this line is beta. So basically, I'm dealing with a triangle I'm dealing with a triangle where this is P point, this is O point, this is N point, this is perpendicular, this is beta. Can we talk about cos beta from here? So cos beta would be equals to, okay, one more thing. If I take this perpendicular distance to be small p, so this is small p, right? This is small p and this is small p. All right. So what is base? Base is ON. ON by hypotenuse. ON by hypotenuse. Hypotenuse is P. So what is ON from here? ON from here is small p cos beta. ON is small p cos beta. So why we have calculated ON now? Actually, I want to find the coordinate of P. The coordinate of P means again the same thing. Na? I drop a perpendicular to the y-axis, I drop a perpendicular to the x-axis, I drop a perpendicular to the y-axis, z-axis, and all those foot of the perpendicular gives me the coordinate x-axis, y-axis, x component, y component, z component. So just like the same, or we can drop it here perpendicular and then go to y-axis, x-axis, one and the same thing. So that ON is basically giving me the y component, P cos beta. Similarly, what will be the x component and z component? P cos alpha and P cos alpha and P cos gamma. So would be coordinate of P would be P cos alpha, P cos gamma, cos beta, and P cos gamma. Okay. Acha, now if the what we are trying to do, please try to understand here. Normal form of equation of plane actually finds equation of plane given two information about the plane. Number one, it provides you with that uh, perpendicular length from origin to the plane. And number two, it provides you the direction angles, alpha, beta, gamma of that line OP. Okay. So in the normal form of the equation, given is given is OP is equals to small p, which is perpendicular distance from origin to plane. That is first thing given. Number two is this is first. Second thing given is direction angles of OP. Direction angles of OP as alpha, beta, gamma. So that means if alpha, beta, gamma is given to me, small p is given to me, that means in the final answer, in the final expression of my equation of plane, I can use small p, I can use alpha, beta, gamma. Okay. So that's what I'm trying to find out using these two. Now, using these two, how will I find? What I have learned? I have learned that I can actually find equation of a plane if I know a point on the plane. A point on the plane. That's why we were trying to find the coordinate of that P point. Because P is a point on the plane. And I just have done a concept where I can find the equation of a plane passing through a point. So if I find out that P point, which I have, so P cos alpha, P cos beta, so coordinate of P, where P is this, where P I have already defined, where OP is P, and alpha, beta, gamma are direction angles. Are direction angles. Let us take any arbitrary point Q. Now, what I'm trying to do is, I have a point, right? I can actually find the equation, but the problem would be that I'll still be left with three constants. That means if I have this point given, so what will be the equation of plane? A x minus p cos alpha plus b y minus p cos beta plus c and z minus p cos gamma. But I cannot accept this equation because I have some unknowns here, A, B, C. I have to eliminate those also. So to eliminate that, what I'm doing instead, I am taking an arbitrary point on the plane. So that arbitrary point will be x comma y comma z. The equation involving that x comma y comma z is the equation of the plane because that point is on the plane. Let us take any arbitrary point, any arbitrary point on the plane, arbitrary point q. Okay, then direction ratios of PQ. PQ is a line, then P is also a point on the plane. Q, I have taken a random point on the plane. Let me take it here or anywhere. And it can be anywhere basically. So we can easily find the this is an arbitrary point, so it has to be x comma y comma z. So I can find direction ratios of PQ. How? X2 minus x1, y2 minus y1, z2 minus z1. So direction ratios of PQ. Then direction ratios of PQ are x minus p cos alpha, y minus p sin cos beta, and z minus p cos gamma. And what are the direction ratios of this OP? O is 0, 0, 0. And this is p cos alpha, p cos beta, p cos gamma. So I know the coordinates of both the points. And direction ratios of OP are p cos alpha, p cos beta, p cos gamma. Just a second. Uh, I have calculated direction ratios of these two lines because I know the angle between these two lines. OP is perpendicular to plane. That means it is perpendicular to every line on the plane. So it is perpendicular to PQ also. PQ is a line on plane. Since OP is perpendicular to PQ, therefore, and these are what direction ratios? So A1, A2 plus B1, B2 plus C1, C2 will be 0. So P cos alpha x minus P cos alpha plus P cos beta pi minus P cos beta plus P cos gamma P cos gamma and Z minus P cos gamma, that is equals to 0. Solve it. I have the coefficient of x as, so this is the relation I'm getting in xyz. So this is the equation of the plane. P cos alpha x plus P cos beta y plus P cos gamma z minus P common. In fact, P square common. P square common, and I'll get cos square alpha plus cos square alpha plus sine plus cos square beta plus cos square gamma. You very well know what is that. So now I can take P throughout common. P and P square. So P I can take common. So I'll get cos alpha plus cos alpha x plus cos beta y plus cos gamma z is equals to P. Okay, P was taken common here. This became 1. So there was left with only minus P. I have taken that minus P over here. Plus P. Or this equation is also written as, what is cos alpha, cos beta, cos gamma? That is Lx plus My plus Nz is equals to P. This is how you find, and there are no constants involved here. No unknown constants are involved here. You know L because you know alpha, beta, gamma. So you know cos alpha, cos beta, cos gamma, and P also is given. So the equation is only in the terms of what is given to you. So you can easily find this. This is known as normal form of equation of plane. If you see again, this is actually ax plus by plus cz plus d is equals to 0 kind of equation. But because p is the distance, so that has to be positive. The d is a constant in a general equation. So d can be positive, negative, anything. But p over here has to be positive, and the constants lmn has to satisfy the relation L square plus m square plus n square is equals to 1. So there are some different things. Okay, next is intercept form. Intercept form, first let's talk about what is the intercept form of a straight line. Intercept form, what is the meaning of intercept? Intercept means in xy plane, your line is intersecting x-axis at A, y-axis at B. Then the equation of this line L is very simple. This is called intercept form. So intercept form of line L would be x divided by A, x divided by the intercept on the x-axis, y divided by the intercept on y-axis, plus y divided by B is equals to 1. So, Same things you can do in the plane. If plane cuts x-axis, y-axis, z-axis at the point 2, 3, and 4. So what will be the intercept form of this plane? Intercept form of this plane would be x by 2 plus y by 3 plus z by 4 is equals to 1. Simplify that, you'll get 6x plus 4y plus 3z minus 12 is equals to 0. And as you can see, it is of the form ax plus by plus cz plus d is equals to 0. Minus 12 is equals to 0. Okay. So what is intercept form? Acha. I will write intercept form because you already know what it is. But you can find out also from the concept that we have done. What we have done, we know normal form of equation of plane is cos alpha x plus cos beta y which is um, what is cos alpha, cos beta, cos gamma? Cos beta was on by p. What was on, by the way? On was actually y, है ना? That's why y was actually p cos beta. And what was that xyz? That was a general point. And any equation involving that xyz is an equation of plane because that point is only revolving on the plane, right? So what is the value of y here? Y is p cos beta. So what is the value of cos beta here? Y by p. Similarly, this is x by p. Just a second. Cos beta is y by p. Cos alpha is y. It is coming the other way around. Just a second. Just a second. If I let me redraw the diagram. The diagram this time would be a triangle, and that triangle, say this is p. Small p is the distance, है ना? So it is perpendicular. Any line passing through it. So any line means let's consider this line. Here this is perpendicular, and if this is b point, so this is 0 comma b comma 0. So this distance is b. It will be different here. Okay. I have taken a general point. And this angle is beta. This angle is beta. So what is cos beta? Cos beta is base upon hypotenuse. So what is cos beta from here? P by B. Okay. Please see the diagram is different here, not the normal, not that diagram. The diagram is here. So beta cos beta is P by B y. That means it is P by C Z and it is P by A x. Basically, I have considered a different triangle this time. So P cancels and it is x by A plus y by B plus z by C is equals to 1. What were the given things here? Given thing was A, which is 0 comma which is A comma 0 comma 0, B which is 0 comma B comma 0, and C which is 0 comma 0 comma small c. These are the intercepts on XYZ. So using that ABC, you have to end up with the relation of XYZ, and here we have the relation. Okay. So what is given here? Given was x-intercept A, y-intercept B, and z-intercept C. Okay. Next we have normal form we have done, intercept form we have done. Acha, if a equation is given to you, if a general equation is given to you, then how can you find out your x-intercept, y-intercept, z-intercept? Means how will you find out that where it cuts x-axis, where it cuts y-axis? So if ax plus by plus cz plus d, a general equation is given, is an equation of plane then it rewritten as can be rewritten as, see, now I want to make this equation in the form of this equation. So basically, I don't want a constant, and constant I want on the right hand side, and that to be 1. So how can I make that? Ax plus by plus cz is equals to minus d. I have to divide over all by minus d if I want 1 in the right hand side. So if I divide, I'll get a divided by minus dx plus b divided by minus dy plus c divided by minus dz is equals to 1. But I don't want coefficients of x over here in the numerator. In the denominator, I want some constants. So I can remove this a, b, c. I can take them in denominator. So it will be x divided by minus d by a plus y divided by minus d by b plus z divided by minus d by c is equals to 1, and this is now exactly looks like your intercept form. So from here, what is your x-intercept, y-intercept, and z-intercept? In a general equation, you can see that x-intercept is given by minus d by a, y-intercept is given by minus d by b, and z-intercept is given by minus d by c. Okay, this I have reduced a general equation into an intercept form. In the next class, I still have some time. Uh, Now let us try. I'll not be able to complete it, but let's start at least. Let's try to convert this into normal form. This is important. Reduction of general equation, reduction of general equation to normal form of equation of plane. general equation of plane to normal form of equation of plane. Now, this is going to be difficult because the first reason is that I don't just want some coefficients of some coefficients of x, y, z. I want coefficients of x, y, z such that it follows the relation L square plus m square plus n square is equals to 1. That means the coefficients that I'll choose here that should satisfy the relation a square plus b square plus c square is equals to 1. Okay, and here on the right hand side, I want a positive number. So there are a lot of things to take care of. It's not just like if I have ax plus by plus cz plus d, then I can just in this next line I can give it as this representation. It is ax plus by plus cz is equals to minus d, but it's not that simple. First of all, your minus d has to be positive because it's a length, and then a square plus b square plus c square is 1. Then I can say okay that this and this are same. Okay, but we don't have the guarantee to of that. And this one is reduction of general equation to intercept form. To intercept form of the equation. So we'll start by general. We'll start by ax plus by plus cz plus d is equals to 0. Time okay na? Chalo, it's okay. We are going to start our conversation, our discussion from here. Okay. That's it for today. Please try to complete as many questions as you can for direction cosines and projections. Sure. Thank you so much, everyone. Yes, beta, tell me. What's the doubt? Acha. Answer wrong. Okay. Maybe because I just remembered the answer, so maybe it can be incorrect. Just send me the solution. I can just verify. Okay. It's okay. It's okay. It can be. With that far away from the question. Maybe because I remember there was a question and this was the answer. So maybe, you know. So, but all the questions are from the PNG Energy, so you can see also in the book. It is one of the question of the book.
Ma'am, it will be like when we'll take out the direction ratios by x2 minus x1 and then a1 a2 plus b1 b2, that one concept only, right?
Yes, yes, yes. Divided by root, na, because
Under root
direction.
a1 square
Huh,
plus b.
huh. So maybe
So,
maybe that can be the answer.
okay,
Just verify if yours is correct, then I'll change my answer in the next class. Right now, let's keep it like that. Okay.
thank you.
Okay.